Now we get into the control bits of the code, which I encourage people to play with, although it may make the examples a little bit wonky. For example, neck length, that has nothing to do with an example because there's no neck. But segment length, on the other hand, is totally reasonable to change. Currently, what this is saying is this white part right here is 100 pixels long. If I wanted to change this to 200, change this, save it, reload the project, rerun it, and now the arm is 200. So by changing these, you can start to understand the relationship of the bits of code that you're seeing in this file. Another thing is we've got segment length, which in the future I will either call it arm length or leg length, something like that, to be a little more specific to the code that I'm writing. But in this case, segment length and segment thickness. Now, thickness is how thick through the body this piece is. So if I said instead 45, save it, load it, run it, now I get this big thick block. So this just gives you stuff to play with to see what I'm doing. However, let me explain what is going on in my original code. What I've done to implement the posable doll, the draggable and posable doll, is I've created a rounded rectangle. Now you can't see it because these dots are in the way, but what this is, if you will imagine, is a rectangle that has nice rounded edges on both sides. So it goes around and it's all rounded, perfectly rounded. And the point of this is if you round them like that, it makes a nice sort of like joint, juncture area where when it rotates, it doesn't look too ugly. Now it's a little bit offset. I think I've got this arm segment a little bit too far to the right along the bicep, so it should be connected further out, in which case, if I did it right, when you rotated, that little bit of arm segment there wouldn't be showing, and this would look nicer. So I rounded it so that you can rotate around and make it look nice. So that's the joint radius. That's basically telling us how what the curvature of the rounded rectangle end pieces is. So then to calculate the thickness, all I needed to do was take the joint radius, the radius of the turn, do a little bit of math, multiply it by 2, and then I subtracted a little bit off the end just to make the thickness a little bit less. So for our simple joint example, I could manipulate the thickness simply by changing the curvature. So let's make this 24 instead. We run it, reload it, and now we got this kind of blocky, it's not quite right anymore. So you got to play with these numbers to get these curvatures to come together.
It's an interesting effect nonetheless.
Yeah, this is all manipulatable code that you can just play with. No neck length, so let's just take that out of there. Alright, so let's get to the actual code of making things. First thing we're going to make is the cube. In fact, I'm going to comment this code out as we go along just to make it easier to follow. We're going to reload the example. The cube. This cube, I put it right in the table by saying parts.cube, so that gives it a name cube as a field on the table. And then I create a new rectangle. I put it in a group, layers content, which is a group which was created up here. Uses SSK to create an underlay, a content, which is above that, and an overlay, which is above that. This allows us to separate our inputs, like the buttons, and the background image, which is this just checkered bit right here. And then in the content, that'll be where we put our blocks and our arms and stuff. So we got 3 layers sorted nicely. So back to the creating. So this first argument is a display group. Then I say start at 0. So the X is 0, go 40, basically be 40 wide. Start at 0, 40 down, 40 tall. This is going to make a square that is 40 by 40. Then I take and position it by saying cube X is center X. Center X is an SSK variable that comes along for the ride. It's a global variable. It is always the center of the screen. Pardon me, drink of water there. Then I set the color to 110, which is the color code for yellow. If I wanted it to be cyan, it would be 011, I believe, for people who know their color codes. Hopefully I do. There we go. Now it's cyan. Or I could manipulate these between 0 and 1. Any value between 0 and 1. This is the red channel, the green channel, the blue channel. Right. Next, and this is a very important part, I use the physics library add body function. I pass in a reference to the cube, which I created above. I tell it that I want the body type to be static, and I want it to use these parameters to set up the details of the body. I'm going to give it a density of 1.0, which you need to specify because I'm not 100% sure, but it used to be that the density was arbitrary. I don't think it was set to default to 1.0, and so you could get sort of like weird behavior when you expected it to be 1 and it wasn't actually 1, because the density of the body is going to tell the physics simulator how to do math on this in terms of how to affect it with gravity, how the inertia changes. So a lower density means a lower inertia, that is easier to start moving, easier to stop moving. Then there's the filter, which is a parameter that is passed in, and I simply pass in a same named table. I could have called this my filter to make it less ambiguous. It would be like this. So the table is passed in, and it tells the physics engine, use this filter parameter, which is group index -1, and that's telling this body, anybody else, any other object created with this same filter will not collide with me. Okay, now there's a little bit here that's kind of confusing, perhaps. The static object doesn't need these parameters, so I'm going to take them out. Yeah, I'm going to take them out. We'll talk about this more when we get to the doll. But what I was doing here basically was changing damping properties. So linear damping says how quickly does a body slow down on its own when it's in motion. If the damping is 0, it will never slow down until it hits something. But if it has a damping greater than 0, there will be a force applied to it as it is moving, which causes it to slow down. Now, if gravity were turned on, it would continue to accelerate downward if gravity was pulling it down, but damping could sort of slow that down, change that effect a little bit, but it would never stop it entirely because gravity is a continuous force that's applied frame after frame, and the damping can only negate part of that. Angular damping is just what you would expect. So linear damping is moving in a line, slowing it down. Angular damping says when the body is rotating, if angular damping is 0, it just rotates forever, never slows down. However, if it's got an angular damping greater than 0, it says take a little bit of that velocity off, the turning speed, frame after frame after frame. So more and more is reduced as it goes along until it stops turning. In your games, you're probably going to want to have some linear damping and some angular damping depending on how you want physics bodies to move and behave. And I have to tell you that making a game with physics, you're going to spend a lot of time tweaking these parameters to get the motion correct versus the other inputs like forces and gravity and stuff. And so you can spend a lot of time messing with this to get it feel just right. But to me, that's the fun part, is the tweaking of the physics to get it to work just the way you like it.
So what I'm hearing you say then is there's not like a formula where you say, oh, well, if you want it to behave this way, then you go in and put this much linear dampening on it.
You know, there probably is a formula, but I have never done. There is actually a physics formula for it, but the problem is that the physics engine in Corona is sort of a black box. I don't know what the code on the inside looks like, so I can't see what math was done. I can only guess. Okay. And I haven't spent the time to evaluate that, like put in 5, put in 4, do the math, see what the difference was, try to figure out what the curve is. I could do it, but I could just as easily tweak it and sort of get used to knowing that 2 is more than 1, and 3 is a lot more than 2, and so on and so forth.
And there's a lot more, and there's another subjective part, right? Which you said just a moment ago is to kind of get the feel that you're looking for.
Yeah, absolutely. At the end of the day, you would not be objectively designing this unless you were trying to create a perfect simulation. You're doing this to make it feel a certain way for fun, and the fun factor is all in the mind of the player. So tweak away.